In this video, we're going to talk about writing equations of rational functions, and I still recommend that you have that guidelines sheet out and ready to go because the guidelines tell us exactly what we need for this to write the equation. So we're going to go step by step and talk about what each of these individual pieces are going to tell us about our graph. So we know it's going to be a rational function, so I know I'm going to have a big fraction. And we're writing an equation that has a whole with an x value of -2. So if we go to our guidelines and we find where it talks about the wholes, so what it says about wholes, it says to find the wholes, we're going to determine the zeros of the common factor. So remember, the common factor means that it's a factor in both the numerator and the denominator. So when we're writing the equation, if my whole has an x value of 2, that means my factor is going to be x plus 2. And again, if it's a common factor, it needs to be both in the numerator and in the denominator. So I'm going to make sure I write an x plus 2 in the numerator and the denominator. For the vertical asymptote at x equals 4, go back to the guidelines, talk about why vertical asymptotes. Now this is the 0 of the denominator, okay? So again, if my vertical asymptote is at x equals 4, I'm going to have a factor in the denominator that is x minus 4, because when I plug in 4, I should get 0. Next, we have the x-intercept at -5, 0. So back to those guidelines. To determine an x-intercept, we are going to find the 0 of the numerator. So again, it's all just about the zeros. If my x-intercept is x minus 5, my factor is going to say x plus 5. And then the end behavior asymptote is going to be 1/3. Again, going back to those guidelines, to determine the end behavior asymptote. So remember, there are 3 situations, right? If it's y equals 0, well, that's not what's happening in our situation. We don't have an oblique asymptote, right? And it does tell us that our end behavior asymptote is 1/3. So that looks like this, which means that the degree of the numerator and the degree of the denominator have to be equal to each other. And then it's the ratio of the leading coefficients. So if we go back to our problem, the degree of our numerator is 2 and the degree of our denominator is 2. So the degrees are equal, right? The numerator and the denominator have to be equal to each other. So that means the leading coefficient of the numerator has to be 1 and the leading coefficient of the denominator has to be 2. Or has to be 3, sorry. So now that we wrote this equation, I highly recommend, because we will have access to Desmos and our graphs, is to go to our graphing calculator and type in this equation that we just created and make sure it has all of the features that we just were talking about. So I typed in the equation somewhere here, right here. So one by one, we can check that it has a whole at -2. So again, if you kind of just click and drag right here, you could see that the graph is going to have a whole at -2. It says undefined. You can't see the whole unless you are literally dragging on that graph. But you can see that right there. Next, it said it has the vertical asymptote at x equals 4. We have a y-intercept at an x-intercept at -5. And our end behavior asymptote is y equals 1/3. Again, you can kind of see that our end behavior asymptote there, if you type that in, is going to equal that 1/3. So again, use Desmos to help you check your answer. And it's all basically about just writing those factors and all about writing those zeros of our function. So same thing with number 2. We're giving you all the same information, but in a graph form instead of words, right? So the first thing is to identify each of our important key features. So we got our whole at 1/4. We got our x-intercept here at -3, 0. Vertical asymptote at x equals -1. And our end behavior asymptote looks like it's here at y equals 2. Okay, so go ahead and try and write that equation. Again, think about all the different pieces that all all the different pieces of the graph that match in the equation. See if you can pause the video really quickly and come up with your equation. Since our whole is at 1, 4, I know that has to have a common factor at the x value of the whole. So I'm going to have an x minus 1 in both the numerator and the denominator. The x-intercept is -3. That is going to be a factor in the numerator. Vertical asymptote is at -1. So I'm going to have a factor in the denominator that goes with my vertical asymptote. And again, the end behavior asymptote is a number. It's not 0. It's not an oblique asymptote. So I know it's going to, again, have to mean that the degree of the numerator and the denominator are the same. So that means the degrees of, the leading coefficients are going to have to be in the ratio of 2 to 1. So you can have a 2 in that numerator, you can put a 1 in the denominator, or just leave it as nothing there. And that would be our equation. Again, if this was our quiz or a test or your homework, I would go to Desmos, I would type this in, I would check that it makes that same graph, and then you know you did it correctly.